in Module 15, we'll be looking at another property of integration. We'll be looking at the substitution rule. Just as the chain rule was significant when taking derivatives, the substitution rule is just as significant. That's because it's the inverse of the chain rule. Let's waste no time getting into our first example. In this example, we'll be integrating the product of the quantity 4x squared plus 3x times the product 8x plus 3, all of this with respect to x. Now, this example will not have a lot of algebraic manipulation. It's been set up quite easily for us, as the first example should be. But as you work through Module 15, you'll be needing to use your algebra to manipulate and arrange the variables in the appropriate place in order to complete the substitution rule. First, we need to notice a function and its derivative. Well, let's notice the first function, 4x squared plus 3x, and let's call this u. It's going to be significant that we can also find its derivative. We'll notice that the derivative of u is 8x plus 3. So we have in our original question both a function, 4x squared plus 3x, and its derivative, 8x plus 3, and these are multiplied together. So the substitution rule is going to work perfectly. So therefore, with our integral, we'll substitute. The 4x squared plus 3x will become u, and the 8x plus 3, its derivative with respect to x, will become our du. And we'll integrate this new function. Now the indefinite integral of u, using our power rule, the exponent becomes 2, and then don't forget to divide by 2 or multiply by 1/2, and also don't forget to add your constant for the indefinite integral. So we have the expression 1/2 of u squared plus c. Plugging back in our value for u, we have our final result, which is 1/2 times the quantity 4x squared plus 3x, all to the second power, plus our constant. We'll look for questions that you might have on the substitution rule on the discussion board.